Hi, today we are going to learn about systems of equations. Specifically, we are going to solve systems of equations by graphing method. Let's begin. Let's define first system of equations. A system of equations is when you have two or more equations using the same variables. For this case, we usually use x and y's. The solution to this system is the point that satisfies all of the equations. This point will be an ordered pair. Again, it's x and y. When graphing, you will encounter three possibilities. First possibility, you have an intersecting lines. The point where the lines intersect is your solution. In this case, the graph shows that given the graph of two equations, it intersects at point 1, 2. X is 1, y is 2. Next case, the case of parallel lines. The lines never intersect. Since the lines never cross, there is no solution. Parallel lines have the same slope with different y-intercept. In this case, as you can see, it shows the triangle rise 2, run 1, rise 2, run 1. They have the same slope, but this line has a y-intercept of 2 and this line has a y-intercept of -1. Third case. It's a case of coinciding lines. These lines are the same. Identical equations have coinciding lines graph. Since lines are on top of each other, therefore there are infinitely many solutions. Why? Because these lines are intersecting all of its points, so therefore it's infinitely many solutions. Coinciding lines, as a description of the two equations, have the same slope and y-intercept, meaning to say these lines have exactly the same slope and y-intercept. And those are the three possible cases. Again, we have the case of intersecting, there is a solution. The case of parallel, no solution. And the case of coinciding, lines are on top of each other, we can conclude there are infinitely many solutions. First example, what is the solution of the system of the graph below? Very simple. Since there's a solution, we just determine the coordinate x first, which is +2, and the next is your y coordinate, -2, and therefore it should be the first choice. Next, what if you are given equation and you are supposed to graph? If you observe, they don't have the same slope, so definitely they can be intersecting, but not all the time. To make sure, we are going to actually solve it. We will use the x and y intercepts. X and y intercepts is that when you are given a line, let me enable my pen. Let's say the line crosses on this point, that's the x-intercept, and this point is the y-intercept, and therefore we can draw the line. By finding x and y-intercept, we can graph the line or the equation. Let me clear this one. So we will find the x and y-intercept of the first equation. How do you do that? You just plug in x should be 0. If this is 0, therefore y is 4. Very easy, right? Now, that's the y-intercept. If x is 0, you have a value of y, and that's the y-intercept. We need the other one. What if y is 0? Then we will find x. So if y is 0, it's gonna become 2x is equal to 4. Divide by 2, x is 2. and that is your x-intercept. Okay, and that's for the first equation. We need both of the two equations. They're each x and y intercepts. We're done with the first, and now we're on second. The second should looks more easier. So first, we are going to look for the y-intercept. We'll make x 0. So if this is 0, watch out, it's not positive 2. Since there's a negative sign to clearly show you guys, you are supposed to divide both sides or multiply both sides by 1. Then it actually becomes a negative 2. And that's your y-intercept for the second equation. Next, what if y is 0? We're looking for x-intercept now. If y is 0, it's quite obvious, you don't need to solve. X is equal to 2. Now we are done. We are now ready to graph your two equations. Graph the ordered pairs, the x and y-intercepts of each equation. Let's proceed. So the first equation has x and y-intercepts of 0, 4, and 2, 0. 0, 4 should be here, and 2, 0 should be here. And we can now draw this line by just finding the x and y-intercept. Next, the second equation, we can also label it. The second equation, x minus y is equal to 2. The y-intercept is 0, negative 2 should be here. And 2, 0 is actually, they share the same point. And connecting these 2 points and extending beyond, we are able to draw the graph of the line x minus y is equal to 2. Remember your 3 possibilities? This should be your first possibility, that there is an intersection. What is the point of intersection? 2, 0. And this is supposed to be the solution. Let's presume we're not sure. Let's check if it is the correct solution. The point 2, 0. To check your answer, plug the point back into both equations, the value of x and y. X is 0, no, x is 2, and y is 0. So if this is 2, 2 times 2, and this is 0, it's equal to 4. On the other equation, if this is 2 and y is 0, it's actually equal to 2. 2 is equal to 2. And therefore, indeed, this is the correct solution. The solution is 2 and 0. The coordinate of the solution is 2, 0. Let's find the solution of the next example. Graph both equations, put both equations in slope-intercept or standard form. In this case, I'll show you the slope-intercept form. This is not in slope-intercept form. To show, you have a negative 2x plus y is equal to 1. The slope-intercept form is supposed to be y is equal to mx plus b, which is the form of the first one. The second one is actually the standard form, so we are going to make it into slope-intercept form. Meaning to say, we only need the y on the left side. To get rid of the negative 2x, we apply the addition property. We add both sides by 2x. This cancels. Y is equal to, copy your 2x first according to the form mx plus b, and then plus 1. And that's why that there it is. They are now both in slope-intercept form. But you need to notice that they have the same slope. Lines with the same slope are actually parallel. Okay. Graph using slope and y-intercept. Do we really need to graph? Let's show. Supposed to be. This is the graph. The first equation, actually, no, that's not the one. first equation is having a y-intercept -3, rise 2, run 1. So that's your first line. The second line is actually has a y-intercept of 1 and slope of 2/1, rise 2, run 1. And so it's actually definitely a parallel line, the case of parallel line. Since there's no intersection, there is no solution. Okay, remember, parallel lines, they do not intersect. No intersection, no solution. Let's proceed. Notice that the slopes are the same with different y-intercept. If you recognize this early, you don't have to graph. Nothing to check because there's no solution. Let's have the last problem. What is the solution of the system? Okay, my strategy is that I'm going to write this into standard form. Anyway, this is not in slope intercept form because it's supposed to be y, but I'm not going to that. I'm going to the form ax plus by is equal to c. So to get rid of 6x on the other side, because the right side should be only a number, which is -16, I'm going to get rid of 6x here. So by subtraction, I subtracted both sides by 6x. This now becomes -6x plus 2y. I just wrote them next to each other. 6x is written first because the x term comes first before the y term. This cancels, and then you have -16. If you are very smart, you noticed that you are after of probably they have the same slope. We can actually divide entirely each term by -3, no, -2. Because we cannot divide by 3 because 2 cannot be divided by 3. After dividing, this becomes +3x, -y, and then this is equal to +8. What do you notice? Do you remember one case of the 3 possibilities? These are actually the same lines. Same equation, same lines. And it will resolve when you graph into coinciding lines. If you're required to graph, you need to graph. But if you don't need to graph, you already knew that they are same lines. It will resolve to coinciding lines. The answer will be infinitely many solutions. Choice 4 is the correct answer. And that's it. Okay? Let's summarize. There are 3 steps to solve a system using graphing method. First, graph both equations. Graph using slope and y-intercepts. Or, remember, graphing using slope, which is your triangle method, and then y-intercept. The other option, of course, the ones being shown here, the x and y intercepts. See which one works for you and which one is easier. Be sure to use a ruler and graph paper. Step 2, do the graphs intersect? If there is an intersection, that is the solution. Label it using the x and y coordinate. Which is your solution? To make sure that you got the correct solution, you can do a checking. Substitute the coordinate x and y's into both equations. It should make both equations true to be considered a correct solution. Okay? That's the end. We can have more examples on your worksheets. Thank you.